So welcome to this is the Further Math Support Programme online revision session for Edexcel Stats 2. And in this session we're going to be looking at continuous random variables. So the things you need to be able to do, you need to be able to understand and use the definitions of the probability density function, the PDF, which we always notate as little f of x, and also we need to be able to find it from big F of x, which is the cumulative distribution function, which we call the CDF. So if I gave you the CDF, you need to be able to find the PDF. If I gave you the PDF, you also need to be able to find the CDF, and make sure that you are comfortable with interchanging between the two. From the PDF and or the CDF, depending on what you're given and what is the most convenient to use, you also need to be able to work out all of your descriptive statistics. So you need to be able to work out your mean, variance, mode, median, and quartiles. Sometimes, particularly with the median, it's not possible to calculate, so you are expected to use core 3 techniques, sort of trial and improvement, interval bisection type things, to be able to solve those, and I'll show you that as we go along. So, January 2011, question 5. We're given a continuous random variable x, and we're told what the PDF f of x is, and it's shown in the picture below. So what we've got to be able to do is we need to be able to show that f of x is equal to 4 minus 8x as long as we're between 0 and 0.5. This thing here is called a support, by the way. And we have to specify for all real values of x, and again that's a situation where students go wrong. So this is really a core 1 question in disguise. They're asking you to find the equation of the line that covers the axes here. Okay, so that's absolutely fine. So if we find the gradient first, we can find the gradient of this line by looking at the change in y over the change in x, which is going to give me minus 8. So now I know that y is equal to minus 8x plus a constant, and of course we can see that that y-intercept is in fact 4, as we can see from the graph. Okay, so this is just a bit unfamiliar. So you're going to get 1 mark for finding the gradient. You're going to get an accuracy mark for demonstrating you're using the y-intercept. So we need this plus c. We need then for you to demonstrate that you know what that means. So it's the specifying for all real values now that's important. So what that means is f of x. Now we need to define it for all real values. So that means x going off in both directions here as well. So just gone over that in blue so you can see what's going on. So it's equal to 2 things. Either it's equal to the function we're dealing with, if we are between 0 and 0.5. Otherwise, it has a value of 0. So that is the standard way of writing that. So you get 2 marks, two independent marks for getting that correct. So we're then asked to find the CDF, big F of x. Now by definition, big F of x is equal to the integral from the smallest value in the support, which in this case is 0, up to some given value, which I'm going to call x. So really it's an area formula. And just because of how integration works, we're not allowed to then use x inside our function, so we have to use a dummy variable. Now the mark schemes don't really make an effort with this, but my advice is you should always introduce a dummy variable here, just in case. Okay, so if we now integrate this, this is going to give me minus 4t squared plus 4t between 0 and x, and if we substitute that in, that's going to give me minus 4x squared plus 4x. Okay, now some of you may have used a different method for doing this, where you haven't got limits and you find your constant of integration, and you use the fact that either f of 0 is equal to 0 or f of 0.5 is equal to 1. That's perfectly fine, but you need to make sure you're demonstrating all of your steps. Okay, so we've got 2 method marks so far out of 4. Because again, like with a PDF, we need to ensure that we are fully defining this. So f of x is equal to, now it's equal to 3 things. It's equal to 0 if you are below your smallest value, and that's because you haven't added any probability in yet. It's equal to minus 4x squared plus 4x if we are in the support. And then if we go beyond 0.5, we've actually added everything in. So there's no more probability to add in, so it must be 1. So this is where you get 2 marks. You get an accuracy mark effectively for getting this section here, and then you get an independent mark for getting big F fully defined for all real values of x. We're then asked to find the median of x. So there is a definition. The median of x is the fact that m is a value such that the cumulative probability below it is equal to 0.5. So in this case, what we need to be able to do is we need to make sure we're choosing the correct support. Now, there's only one support here to worry about, so that's not so bad. So we substitute m into this aspect, so that's minus 4m squared plus 4m, and we're left with a quadratic to solve now. It's always a good idea just to make sure that you've got this in a sufficient setup. Okay, so it's a question of solving this. Now you can use the formula, you can complete the square, any of those would be fine. If you do that, you end up with m equaling 2 minus root 2 divided by 4, and that's going to give me a value of 0.146. Always check that your answer is within the support. The reason is this: if you solve it, you need to realize you're going to get two answers, and this answer is bigger than 0.5, so therefore it can't happen. Okay, your median has to be between 0 and 0.5, so that's how we know that this is going to be the answer here. So you get, for this question is 3 marks. You get 1 mark for substituting in m and trying to solve the equation. You get 1 mark for effectively trying to solve a quadratic, and an accuracy mark for getting the correct answer as well. We're then asked to write down the mode. Now, the definition of the mode is the highest point over the support. So if we look at the graph, we can clearly see here that the mode is actually equal to 4. Now, if you're not given the graph, you also need to be aware that the mode could be a turning point. Okay, so in other words, we could be looking for where f prime of x equals 0. It's either going to be an endpoint or a turning point, just to make sure you're aware of that. Okay, so you get 1 mark for that. So, sorry, the frequency is 4, so the mode therefore is equal to 0 in this particular case. Okay, so that's the value of f of x. It's the biggest value. So state with a reason the skewness of x. So this is going back to stuff from S1. What we can notice is that the median, we don't have the mean, so we can't use that. The median is greater than the mode. Okay, now hopefully you should be aware that if you write these things in alphabetical order, obviously we don't need that one, your inequalities are all pointing that way, so therefore this is going to give me positive skew. Okay, now you only get 1 mark for this, and that's for stating it's positive skew and with a reason. That's to avoid you from just guessing. Okay, so you need to make sure you're giving a valid reason for that. So this time in this question, June 2010 question 4, we're actually given the lifetime in tens of hours. It's always useful to make sure you're aware of your units, of a battery has a cumulative distribution function. So this time we are given big f of x. So as before, we're then asked to find the median of x, giving your answer to 3 significant figures. Now, bit of advice, make sure you're giving your answer to 3 significant figures. If you don't, you will lose an accuracy mark. So again, as before, the definition is it's a value m such that its big F is equal to 0.5. Substituting that in, we get 0.5 is equal to 4/9 of m squared plus 4m minus 3. And now it's just a question of solving that. So if I just rearrange this and tidy it up, you'll end up with m squared plus 2m minus 4.125 is equal to 0. So again, it's probably best to use the formula here. If we do use the formula, we get m equaling minus 2 plus or minus the square root of 4 plus 16.5 all divided by 2. And that's going to give me 2 answers again because it's quadratic. So m is going to be 1.26 or it's going to be minus 3.26. Minus 3.26 is not in the support, so we're not interested in that one. So the median will be 1.26. So you've got 3 marks for this. You get the first mark for creating the equation and substituting m in the first place. You could use X, but M for median seems a little bit better. You then get a method mark for attempting to solve the quadratic, and again the formula is by far the most efficient way of doing it at this level, and then you get an accuracy mark for getting the correct answer. If you just leave it as 1.26 and minus 3.26, you will not get that final mark. You do need to discount the incorrect value. So now we're asked to find, again in full, the probability density function of the random variable x. So little f of x is defined as being the differential of big F of x with respect to x. Okay, if we integrate little f to get big F, we differentiate big F to get little f. So that's quite nice. Most of the functions you're going to be dealing with are going to be nice polynomial, nothing particularly nastier than core 2 integration or differentiation. So please make sure that you can do that. Okay, so we want to differentiate this, so we're going to be differentiating. Always worth taking your time over these and making sure that you have them correct. So I'm just writing it out and expanding it. So that's going to give me, if I do this, it's going to give me 8x over 9. Differentiating the next term is going to give me plus 8 over 9. And of course, we like factorising, so that's going to give me x plus 1. So it's now this in full. This is where you get your final mark. So f of x is equal to one of two things. Either it's equal to 8/9 x plus 1 if you are within the support, or it's going to take a value of 0 otherwise. So this is worth 3 marks. You're going to get your first mark effectively for differentiating, which is quite nice. You then get your, you get an accuracy mark for both of those, so you get that, and then again you get an independent mark for defining f of x correctly. So it's quite nice. It's follow through as well, this one, so if you've made a little bit of a mistake previously, you can still get that final mark by defining in full your PDF. So now we're asked to find the probability that x is greater than or equal to 1.2. So this is the same as 1 minus the probability of x being less than 1.2. By definition, this is the same as 1 minus f of 1.2. That's what the probability function is. The cumulative distribution function is the probability up to a particular value. So all we do for this is we substitute 1.2 into your equation. So it's 4/9 1.2 squared plus 2 lots of 1.2 minus 3. Make sure you're substituting it into big F and not little f. That's a common mistake that we just need to be very, very aware of. So this is going to give me 1 minus 0.3733 if you evaluate that, which is going to give me an answer of 0.627 if you write it to 3 significant figures, which is what we are generally needing to do. So 2 marks for this. You don't get many marks. You get 1 mark for recognizing that it's 1 minus the cumulative distribution function, and of course 1 mark for getting the correct answer, and there is no follow through with that either, so just be aware. Okay, so the question keeps going. Some of these really do keep going. A camping lantern runs on 4 batteries, all of which must be working. 4 new batteries are put into the lantern, and what we're asked to do is to find the probability that the lantern will still be working after 12 hours. So we notice that 12 hours corresponds to 1.2 lots of tens of hours. So for this to work, each battery still has to be working. Otherwise they're all going to go out. So let's say battery 1 still has to be working, and battery 2 has to be working, and battery 3, and battery 4. So each one of those has to be still alive after 1.2 hours for it to be working. Now they're all coming from the same distribution, so in other words this is going to be the probability of x is greater than 1.2 to the power of 4. And we've worked that out in the previous part of the question, so it's 0.627 to the power of 4, which is going to give me, again to 3 significant figures, 0.154. So it's a lot of thinking for 2 marks. This is very much an A-grade descriptor question, really, about trying to adapt the situation. So you get 1 method mark for understanding and realizing that they're independent events, and we need to raise it to the power of 4, and then one answer for getting the correct accuracy. So June 2011, question 7. This is a very long question, so it's got like 8 parts, I think. So sometimes you really are in for the long haul with these, and it's worth making sure you're doing this. And it's worth recognizing and learning some of the skills that you have from core maths. So we're asked to sketch f of x. Okay, we're asked to sketch this probability density function. Now looking at it, you need to realize something. You need to realize that it's a negative quadratic. Okay, we know that because we've got x times minus x, and also it's nicely factorized for us, and that really does make life very, very nice indeed. Okay, so when we come to sketch it, again, we're only looking for the key points. So we need to recognize that the support goes from 1 to 5. It's going to have zeros at 1 and 5. I know that because of the factorizations. And it's going to be symmetric parabola. Okay? So anything like that would be quite useful. Okay, so that's my sketch, which is really, really quite nice. We need to make sure that these points here are labelled for you to get the marks. It then says write down. Now don't forget, write down means that you shouldn't really need to do much work. So we're asked to write down the mean value of mu. Now this is a symmetric distribution, and the symmetric distribution, the mean will be in the middle. So we can see that the mean here is 3. Okay, so 2 marks for the graph. You get 1 for noticing that it's a negative quadratic, and you also get your second mark for it touching the x-axis at 1 and 5 and it being labelled. So part C, we're now asked to show that the expectation of the square of x's is equal to 9.8. So by definition, the expectation of x squared is equal to the integral over the support, which is going from 1 to 5, of x squared times by f of x. Now there's only one f of x to worry about, so this is going to give me, if I multiply out the brackets, I'm going to get minus x squared, multiplying these out, there we go, minus x squared, minus 5, and we're going to get 6x in the middle. Okay, so always just make sure you do that first. It's very easy on these questions to forget to integrate because you've expanded and it looks like integration. So just take your time with these and everything will be fine. So that's going to give me minus x to the power of 4 plus 6x cubed minus 5x squared times by 3 over 32. I like to pull it out of my integral just because it gets in the way if we're not careful. So carrying out that integration, that's now going to give me 3 on 32. Let's do these in this order. So that's going to give me 6x to the 4 over 4 minus x to the 5 on 5 minus 5x cubed on 3. And then we evaluate that between 1 and 5. And if we do that, again, you need to demonstrate that you're substituting in the values. It's not good enough just to now write equals 9.8. And the reason is because the answer is shown. So we need to demonstrate that you're going to substitute in your values. So let's just do that really quickly. That's going to give me 6 times 5 to the power of 4 over 4 minus 5 to the 5 over 5 minus 5 lots of 5 cubed over 3. And then the same with 1. Sufficient use of brackets, so it's 6 over 4 minus 1/5 minus 5 over 3. By doing that, you've demonstrated sufficiently that you know what's going on, so that's going to give me 9.8 for that. Okay. So we're then asked to find the standard deviation, sigma. So sigma is equal to the square root of the variance, which is useful, and we know that the variance of x is equal to the expectation of the squares minus the square of the expectations. So we've just worked all of this out. Always use the values that are given. So we were told to show that the expectation of x squared was equal to 9.8, and we've written down that the mean is 3. Please write it as 3 squared in the first instance, just to demonstrate you're using the formula. You can then calculate it through, so that's 0.8. So sigma will equal the square root of 0.8, which is going to give me 0.894. Again, 3 significant figures. So 2 marks, one for recognising it's the square root of variance and doing the calculation, and then your accuracy mark for getting 0.894. So then we're given a cumulative distribution function of x, and it's given us this. So they've done a lot of the work for us, which is very nice, but we're asked to find out what the value of a is. Now there are 2 methods for doing this, but it recognises the fact that f of 1 must equal 0 because there is no probability added in yet, and f of 5 is equal to 1. So there's only one thing we're asked to find, which is a, so we can use either of these. What you might find in some cases is there are 2 variables to find, a and b, and of course you would then need to use both values to work out the values of a and the values of b. So I'm going to use this one here because that seems to be the most sensible one to use. So it's a question of substituting this in. So here we go. So 0 is going to be equal 1 over 32 times by a minus 15 plus 9 minus 1. That's why it's so nice to use 1, because powers generally work out quite pleasant. So tidying that up, we're going to end up with the fact that a is equal to 7 if you work that through. So you get 2 marks, 1 for doing the substitution and then 1 for working out the value of a. So we can substitute the value for a, and you can do what I've done here. What I recommend in questions is to, once you've worked out a value, cross it out, replace it with the value that you've worked out, so when you're referring back you know that. And now we're asked to show that the lower quartile is between 2.29 and 2.31. The definition of the lower quartile is f of q1 is equal to 0.25, but because this is a general cubic, you don't really have any techniques for solving that. So this is why it's a show that question. So what we need to be able to do is recognize that if you substitute 2.29 in, that should be less than 0.25, and if you substitute 2.31 in, then that should be greater than 0.25, using some ideas from core 3 in that respect. So if we do that, let's see what we get. So if we substitute 2.29, you can do all of this on your calculator. You don't need to demonstrate your working out. We just need to make sure that we've got a value that is below. It has to be the correct value, of course, but we need a value below and a value above. Okay, so that's going to get me 2 marks. We then need to say this. So since this information is true, then it's really important, this you're trying to show. So 2.29 is less than q1 is less than 2.31. So you get 2 marks for substituting the values in. You then get 1 mark for getting your final statement. Hence, lovely word in mathematics, use what you've just done. Okay, so hence find the upper quartile of x, giving your answer to 1 decimal place. Now what we need to realize is that this thing is absolutely symmetric. So we've worked out that the mean, therefore the median, is equal to 3. The lower quartile is equal to, well, we can use 2.3 because if rounding and things like that, that would be sufficient. So we can see that we are 0.7 below, so we are going to be 0.7 above, and that's going to give me the upper quartile. Okay, so you only get 1 mark for this, but it's this recognition that you're dealing with a symmetric distribution that's going to enable us to do this. Finally, again a bit of a weird but interesting question, we're asked to find to 2 decimal places the value of k so that mu minus k sigma is less than x is less than mu plus k sigma is equal to 0.5. So looking for the sort of middle, the values that are going to give me a middle 50%. So there's quite a lot of information that we know. It's asking for the middle 50%. So surely this is Q1 and this is Q3. It's useful just to observe and notice these probability factors. See, there's a lot of S1 that they're testing here as well. So it's very, very worthwhile. So we're looking for the probability of being between 2.3 and 3.7. And we therefore know that mu minus k sigma is equal to 2.3. We know that mu plus k sigma is equal to 3.7. And we can do some work on this to basically tidy it up. And if you work this out, we can see that k sigma is going to equal 0.7. Okay, if we subtract these two equations, we get 2k sigma is equal to 1.4. So K sigma is equal to 0.7. We know what sigma is because we've worked that out in a previous question. Sigma is equal to 0.894. So as a consequence, K must equal 0.7 divided by that, which is going to give me around about 0.78. Okay, and generally they are a little bit more lenient in the rounding. If you want three significant figures, it's 0.783. So this is a very, very involved question that is relying on you going back and forth between the parts to make sure that you get the right answers. So a few pieces of advice going forward from this. Please make sure that you can find big F of x when little f of x has got multiple supports, and also make sure that you can find medians when you've got multiple supports on big F of x. That's quite an important skill that you could do with making sure that you're happy with.